Thank you, Jenna. So, today we're starting day 3. There's only 4 days of notes. So on Tuesday when we come back, I don't like the timing of this unit. We have a long weekend right in the middle of it, and we started off with the spring break. So Tuesday we come back, we will do the last day of notes. Then Wednesday I don't see you guys. The test for this chapter will be on Thursday of next week. Right? But we'll do a review and a test on the same day. Right? And I hope that it gets easier. It's happened in the past for my class. Most students find it easier as this chapter progresses, but we have that long weekend in between here, which makes things a little bit more difficult. So today, we're looking at solving equations which have brackets. So we have to do a little bit of bed math, right? Now, in the previous chapter, I talked about something called the distributive property with the polynomials, okay? And it's okay if you don't remember it. So normally, if we have a question like this and we're doing bed math, we'd go 3 plus 4 is 7. Then we multiply it by 2. We do the stuff in the brackets first, and is equal to 14. And in the last chapter with the polynomials, we talked about the distribution property. It said sometimes the stuff in the brackets we can't combine, right? So how do we simplify? How do we distribute? So we said we could also go the number outside and multiply everything inside. We said 2 times 3 is 6, and 2 times 4 is 8. And 6 plus 8 still gave you 14. So it was just another way to approach it. Now, there's no reason why we would do it a question like this, the second method, other than to demonstrate that the fact that these two things do give you the same result. So in a question like this, right here, we have x inside the brackets. And we can't combine anything inside the brackets, so there's no way to solve it if we didn't use the distribution property, because we need to get the x outside the brackets. So what we do is we apply the distribution property to make the x a single term by itself. So you go 4 times x is 4x. And we go 4 times 0.6, which should be 2.4. All right? Now, Caden, E, is this a positive 2.4 or a negative 2.4? Negative. Thank you. And this still equals a 3.2, right? So now this becomes like a question that we were doing before. So we don't need to worry about the 3.2. The side that we're concerned with is the side with the x on. So this side of the equal sign. We have a 4 and a 2.4. Which one do we move away first? Yes, Riley? 2.4. Right? We add 2.4. And when we were doing the quiz, some people wanted to move away this 4 first. And technically, you can do it. But you don't subtract 4, you'd have to divide 4, and you divide 4 every single term. So that's why we add and subtract, because it makes it a little bit simpler, because when we're dividing, we're only dividing 2 things. So we end up with a 4x here. These cancel out. And we're left with a 2.4 plus a 3.2, which is 5.6. Then we still have this.
Divided by 4? You gotta divide by 4 now?
Now we have to divide by 4 to get rid of this. The 4's cancel out, and once each side, every term gets divided. Now, since our numbers had decimals in it, we actually calculate this out. If it's whole numbers, you leave it as a fraction. As decimals, calculate it out. 5.6 divided by 4. 1.4, thank you, Izzy. 1.4, and that is your answer. Okay? So let's do another one together. Then I cross this middle one out. It's a repeat. I made a typo when making up the note. Okay? So there's no way we can isolate the x since it's inside the bracket. So we use the distribution property, right? We multiply it out. So if I multiply the first 2 things, what do I get? 2x. Multiply the 2 to the second term. Negative 8. And we still have the equals, and I have the 12. And notice, I'm stacking this right above each other so I don't get lost. I can check. I did this calculation. I did this calculation. This carried down. Right? It's nice to keep it vertically lined up like that. Okay, now x is over here. Two numbers, a 2 and an 8. Which one do we move first? 8. Add, subtract, multiply, or divide it, Caden.
It's subtracting right now, but you add it.
Add it. And add it. So the 8's cancel out. We're left with a 2x is equal to 12.
Equal to 20, so 20 when you think
Oh, sorry, 20. That's right. 20.
Divide by 2.
Then we divide by 2. Divide by 2. X is equal to 10. All right? I'm going to make a little squiggle here. I'm going to write this step right here out again. Now, when we're doing the quiz, some of you guys said, Mr. Dollywall, can I do the 2 first? Right? And I showed you this at the beginning of the unit. My answer to you is yes, but you got to do it properly. And that probably didn't help you on the quiz. If you wanted to do that 2 first, you have to divide to get rid of that 2. Remember when the rules for dividing is, and multiplying, everything, every term gets divided. So if you wanted to divide by 2, sure, go ahead, do it. But everything needs to be affected. So then the first term becomes 2's cancel out. You just left with the x. The middle term cancels out. 2 goes into 8 4 times. A minus 4. And 12 goes into 2 goes into 12, 6. Right? Then we go, hey, on that side, there's only a plus 4. So you add 4. And x is equal to 10. Right? Now, just stick with the method you're comfortable with. But when you ask me a question, you're getting to a point in math, there's more than one way of doing things. So my answer may be yes, but I know that you have to fully execute it correctly. Now, Harmon had an excellent way of solving one of the questions on the quiz, which I hadn't shown you, but he realized something. So he was moving terms around the left side of the equation, the right side of the equation, which made it a lot faster, right? But he did make one tiny mistake. But what he was thinking one step ahead. It showed me that he understood quite a bit. But there's lots of different ways of doing things. You just need to be correct about it. And you can ask me about it, but quiz is not the right way. But on assignment and stuff like that, I can talk to you a little bit more. Because there's little subtle nuances you need to be careful about. So try this one by yourself. Remember, the first step is just to multiply this through the brackets. Then solve it. All right. So, helping me out. We do the first multiplication. What do we get? 1.2 times x. What does that give us? Okay, doing the second multiplication. What does that give us?
3.6.
3.6. Positive or negative? Positive. Don't forget your equal sign. 2.4. Okay. Got 2 numbers sitting there. Which one do you move first? You can move any of them. All right. Add, subtract, multiply, or divide it to get rid of it. Minus. Minus. All right. These cancel out. 2x and 2.4 minus 3.6.
Negative 1.2.
1.2?
Negative.
1.2. Okay. Yep. Then we need to get rid of that 1.2 on the left-hand side. Divide. We're just multiplying right now. Divide. 1. Negative 1. Okay. Now to make your life a little bit harder, we can have multiple brackets and multiple numbers. The process is the same, except for now we have lots of terms that we need to collect. So we start off with this one. We go, you multiply those together, 1.2 times 2.3, 2.6. That doesn't sound right.
It's 2.76.
2.76. Okay. Multiply the next together, it just 1.2x. Okay. Now this number outside this bracket only gets applied to this bracket here. Then we move on to the next bracket. You have this 2.6. This can multiply everything inside this bracket.
8.06.
We have 8.06.
Is that negative?
Is it negative?
Yeah.
No. Oh, yes, sorry. Yes, it is. Negative. Yeah. Next one. You multiply it through 2.6x. Is it positive or negative?
Negative.
Positive. Yeah, positive, right? It's negative.
Positive. We have a negative 2.6 being multiplied to a negative x. So that would be two negatives make a positive. Right? And this equals 4.5. Now, like one of the questions on, I think it was G there, that sort of confused some people, is we have lots of terms here. We need to collect them. And so this is sort of like what we did in the last unit. We have a number here and a number here. These are like terms. These can be combined. We have a positive 2.76 and a negative 806. So 2.76 minus 8.06 gives us negative 5.3. Is that okay? We're just combining things that are alike. We have a x here and an x here. We combine those together. We have a negative 1.2 and a positive 2.6. Negative 1.2 plus 2.6 gives us a 1.4 x. Notice I didn't add the 4.5. That's on the other side of the equation. Just combine the stuff on the same side. Yes, Carter?
Would it be x squared?
No. When we multiply,
Yeah, that
the
is-
powers add.
Yeah.
All right? Good question. Thank you for asking that. So it equals 4.5. Okay. We have two numbers there on the side of the x. Which one do we move over first?
Plus
5.3?
5.3.
Yes. 5.3, and we're adding it. There's a negative 5.3 on that side, so we add 5.3 on this side. So the 5.3's cancel out. We're left with a 1.4x. That's a 9.8. It looks like it adds up to be.
Yeah.
Okay, then we have the 1.4 sitting there.
You gotta divide that now again?
We got to divide it. Which is multiplying the x. Divide it. So what does it equal, Harmon? Did you do it? Thank you, Harleen. 7. Okay. So if you have multiple terms on the same side of the equation, look to see if some of them can be added or subtracted together. Now, yesterday we worked with fractions, and we said, hey, if we have fractions, we're going to avoid them by turning everything into integers. And we're going to do the same thing here. Now, the only difference between what we did yesterday and today is our numerator is more than one term. Yesterday, everything was just an x over a number, or just a number over top of a number. Now we have a little x minus 1, or a 3x plus 2, or something like that. But the process is the same. We look at our denominator and go, we want to get rid of our fractions. We go, what's our common denominator? We have a 2 and a 4. So what would be a common denominator? 4. And we multiply everything by 4. So when I say everything is each term. So we have this fraction and this fraction. So this fraction gets multiplied by 4. And when I say this fraction, everything on the top gets multiplied by 4. So put little brackets around the top to highlight the fact that everything in the top can get multiplied by 4. And over here as well, multiplied by 4. Then what we did last day is we did this to get rid of those fractions. So we compare the bottom number, the denominator, to the number we multiplied and see how we can reduce that. 2 goes into 4 how many times? 2 times. So cross off the 2, cross out the 4, and 4, it goes into it twice. So this side can be rewritten as 2x minus 1. 2 times whatever is left over in the top. On the right side, we have a 4, and 4 goes into 4 one time. So you're left with a 3 times 1. This is just a 3. Okay. Next up is, what do we do? 2x. Is that it?
And then so 2 times x and 2 times negative 1.
Yeah, we need to multiply this through the bracket. 2 times x is 2x, then 2 times negative 1 is negative 2. And we're left with the 3 over there. So on the side with the x, we have 2 2's. Which one do we move first? The first one or the second one?
Second,
Second one. And Carter, how do we move it?
by adding 2.
By adding 2. Right? Adding 2. Adding 2. So we're left with these 2's cancel out. A 2x on this side, and a 3 plus 2, which is a 5. Okay. Last up. Divide by 2. Good. These 2's cancel out, and we're left with x is equal to 5 over 2. Okay. This is where like math 9 just takes on a whole different level from what you're used to, right? This is more like high school style math, calculus style math, right? I felt that when I was teaching grade 8, grade 8 was more of a summary of everything you did in math from elementary school and in grade 7, and with a little bit of new stuff. Grade 9, it's like a whole new beast. It's way different than what you were doing before. But you guys are doing a fantastic job. You guys are understanding it. Unfortunately, we're in a quarter system, so things go fast. So you don't have much time to process. Okay, looking at this question over here, it looks different than the one over here. So what we do is we can rewrite it so it looks more comfortable to what we're used to seeing. This fraction is saying we have a 3 in the numerator and a 4 in the denominator, and it's multiplying this. So I can rewrite this to look like this. It's a little more pleasing to look like. So it's easier to compare things. We have a 4 in the denominator for this whole entire term, 3 in the numerator. All right. Then moving forward, we convert that fraction to an improper fraction. Right? When we do improper fractions, the denominator doesn't change. It's just the numerator that changes. So what should the numerator here be? Anyone remember, Carter?
15.
15, yeah. You go 7 times 2 is 14, plus 1 gives us our 15. Okay. So now we do the same approach we did over there. We go, we really don't want to be working with fractions, so we multiply by our common denominator. What would that be in this case? 4. Okay, so we multiply by 4 here to everything over there. We multiply by 4 here. Okay? And we did this to get rid of the denominators. Right? You go, this 4 goes into this 4 once. Right? So the 1 times anything doesn't change it. It stays the same. So the top is all we're left with. On the second side, we have a 2 and a 4. So you go 2 goes into 4 how many times? Twice. So you're left with a 15 times 2, which is a 30. Okay, now we get to the easy part. I think you guys are get to know how to do this pretty straightforward, right? We multiply this out. 3x. Second term, what's the second term? Negative 24 equals 30 plus 24 plus 24. 3x is equal to 54. Then what do we do with the 3?
You divide it.
You divide it. 3's disappear. And 54 divided by 3? 18. Awesome. I don't think we need to do the next one. Okay. Let's just do the 2 word problems. Okay. Okay. So the first word problem says the perimeter of the square is 49.2. The side length of the square is represented by this expression here. What does the word perimeter mean again?
All the way around.
All the way around, right? So we have this, we have a square. Square means all the sides are the same, right? And they're saying that one of the sides is x plus 4.1. Actually, all the sides are x plus 4.1. And when we add up all the sides, we get 49.2. So typically, when we do perimeter, we go side 1 plus side 2 plus side 3 plus side 4. Right? Now, in a square, all the sides are the same. So instead of going side 1 plus side 2 plus side 3 plus side 4, we can just say the perimeter is equal to 4 times each of the sides. Now, we're told that the perimeter is 49.2. All right? So this equals 4s. But s are just a made up side. We can say x, or s is actually how big each side is. And we can set up our equation like this. Now we can go to solve it. And this is the way, I don't know, the ministry or the textbook wants me to teach you this. There's nothing wrong with it, but I think most students understand it just by logically thinking it out. So I'm going to stop this question at this point and just talk about it. So if we have a square and the perimeter is 49.2, and I asked you how big is each side, what would you say? How would you calculate how big each side was?
Divide by 4.
Divide by 4. So each side is 49.2 divided by 4. What is that number? 12.3? That doesn't look right. Is it 12.3? Yeah, it is. 12.3.
Yeah, it is.
All right. Now, if we said, we also said that each side is equal to this. How big is x?
I heard that. I heard that. From
We probably even got on the microphone here.
I heard that with my ears. I heard it with my nose. With your eyes.
All right. Mr. Voss? Oh, yeah.
What did I do wrong now?
Oh, we heard your, what is it, blasphemy on my microphone here.
Pardon me?
Okay. All right. So, what would the value of x here be? All right. How do you find the value of x?
Can you flip the question around? Put 4.3 at the bottom. 4.1 minus 4.3.
Yeah, you subtract it. 4.1 minus 4.1.
Oh.
X is equal to
8.
8 point something, right? 8.2? 8.2, right? So I think most students can do this a lot easier than this, right? If this is like fail proof, if you can get this, you'll get your answer. Sometimes you just don't see this. So I'm going to use this same method on the next question. So if we have two equilateral triangles, what does an equilateral triangle mean?
They're all equal.
All sides are equal, right? And they differ by 1.03 meters. So that means we have a big one and a small one. They say the larger one has a perimeter of 9.24 meters. Determine how big one side of the smaller triangle is. Okay. So we're comparing sides of the triangle. So if you said the perimeter of the larger triangle is 9.24, how big is one side of the triangle?
3.08.
3.08? How did you get that?
Divided by 3.
You divide it by 3. The triangle has...
Minus that by 1.03.
Yeah. Then it has 3.08 meters, right? And then we're saying the small triangle is smaller by 1.03. Small triangle is 3.08 minus 1.03. 2 point something.
2.05.
2.05 meters. Right? So side length of smaller triangle is 2.05 meters. Now we could set up an equation, but it takes a lot more effort. I think if you just understand what's going on, it's a lot easier than actually setting up equations. So you try that approach first. Just try to understand what's going on and think your way through the questions.